For example, a coffee machine dispenses coffee into paper cups. And if you don't already have this data in L1, pause the video and please put this data in L1 right now. You're supposed to get 10 ounces of coffee. Okay, so this would be mu. Mu would be the true average amount of coffee in ounces. That's a quantitative variable. We're measuring it in ounces, so it's mu, not p. Proportion wouldn't make sense. Proportion being 10%, that doesn't make any sense. We're talking about a quantitative variable, okay? So this is what we're supposed to get. This is what the true average of coffee should be. But the amount varies slightly from cup to cup. So here we have this idea of that sampling variability that may not always get 10, but that's what we expect. So here are the amounts measured in a random sample of 20 cups of coffee. So that's our sample size. So we're talking about a quantitative variable with a sample size of 20. Now 20 is on the smaller end, but it's not in what I would consider our smallest kind of category. It's kind of in the middle. So in order for us to have our conditions for inference satisfied, in order for us to be able to use these techniques we're learning, we need randomization, independent, and then we need a nearly normal population is what we technically need. Can't check the population, so we're going to check the data instead, and we need it to look as normal as it can or as unimodal and symmetric as it can, but we're kind of in the middle sample size, so if it's a little bit skewed, we're okay with that. So the first thing I'm going to say is this data is random. I know that because they told me. So it should be independent. We don't need to check 10% condition. My population is in essence an infinite population. My population is every possible cup of coffee this machine could fill over its lifetime. So in general, that's an infinite population. All right, next. Because I have the data, I need to check the nearly normal condition with a graph. Now, whenever you make a graph, you need to draw it on your paper. Let me say that again. Whenever you check a graph, you must draw it on your paper. I hope everybody just heard me say that. All right. So, I've already got my data in stat edit. You should have it in there. To make graphs, we go to stat plot, second y equals. This is a good little review because you all need to know how to do this. Press number 1, turn it on, choose the appropriate graph. I'll start with a histogram. Tell it where your data is. I had my data in L1. And press zoom 9. And as long as this looks roughly unimodal and symmetric, which this does, got that mound shape, that's all we're looking for, we're good to go. So now I need to make sure I draw this on my paper. So I'm just going to come over here on the side, do a quick little sketch, label it, and I'm even going to label these bins, 9.5, 9.64, 9.78, oops. Sorry, 9.92, 10.06, 10.2, and that last one goes up to 10.34. So now it's very clear that I've got these measurements in this graph, and I can see that roughly unimodal and symmetric. So I'm going to continue with the data, or the distribution of coffee is roughly unimodal and symmetric. So it should be okay to use the T19 model. Now, where did I get T19 from? Well, my sample size is 20, and our degrees of freedom for one sample test is n-1, or one sample interval, n-1. So that's where that's coming from. These are the assumptions and the conditions that we need to check in order to use the T models.